Hi guys, so today we're going to take a look at question 1 of the 2017 exam paper 1. So we want to write the function f of x equals 2x squared minus 7x minus 10, where x is real, in the form a times x plus h squared plus k, where a, h, and k are rational numbers. Alright, so essentially they're asking us to complete the square. So we have this function f of x equals 2x squared minus 7x minus 10, and they want us to, it's called complete the square. So, and that refers to this x plus h squared term. Alright, okay, so we have a sort of algorithm for doing this, a step-by-step process for doing this. So first of all, step 1 is take out the coefficient of x squared. Coefficient of x squared. So in this case, we're going to take out the value 2 and then rewrite this x squared minus 7 over 2x minus 5. Okay, that's the first step because we always want to have it in this form, x squared, and then we want it in the form x squared plus bx plus c. Okay, and now the next thing we're going to do, step 2, well, we want to divide b by 2, b by 2. So at the moment we have it in this form, a times x squared plus bx plus c. We want to divide b by 2, and then so let's do that first of all. So our b at the moment, the coefficient of x inside the bracket, is minus 7 over 2. So if we divide that by 2, we'll get minus 7 over 4. Okay, and then we want to plus and minus the square of this. Plus minus b over 2 squared. And you'll see why we want to do this here. Okay, and we do that inside the bracket. So plus minus b over 2 squared inside the brackets. Because we want it to stay the same. So if we're going to add it, then we have to also take it away so that nothing has changed. So we'll write this 2 times x squared minus 7 over 2x plus 7 over 4 squared minus 7 over 4 squared, and then minus 5. Okay, and you might think, well, how is this helpful? And what you might notice here is we can separate this into two groups of terms. So we can combine the first three, x squared minus 7 over 2x plus 7 over 4 squared. That's the first term. And then we have another term, minus 7 over 4 squared minus 5. Okay, and so if we look just at this section, if we try to, we can very easily factorize this. So we see that this is, so step actually this is probably step 5, and step 4 was group terms. And then step 5 will be factorize the first grouping, so the grouping in blue. And because of the way that we've constructed this by adding this, the 7 over 4, it's reasonably easy to see that this is just x minus 7 over 4 squared. And if we want to multiply this out, we can see that x minus 7 over 4 squared would be x squared plus 2 by minus 7 over 4 x plus 7 over 4 squared, which is just x squared minus 7 over 2x plus 7 over 4 squared, which is exactly what we have in the blue. Okay, so we factorize this and we get a square term like we were looking for, and then this other term, minus 7 over 4 squared, which is 49 over 16, minus 5. Okay, and then we want to, step 6, bring the constant out of the brackets. So we want this term outside the brackets. So we'll just add those two together and then multiply them by 2. So we'll end up with 2 by x minus 7 over 4 squared minus 49 over 16 plus 5 is 129 by 2 is 129 over 8. And you could just do this with your calculator. Okay, and so now, well, if we look at it, this is actually exactly in the form that we were looking for, where we have an a times x minus or plus some rational number plus some rational number k. So we've written it exactly in the form that they were looking for. So this is just our answer. We've completed the square for this function. Hence, write the minimum point of f. The minimum point of f. Okay, and so now we're going to see why we would ever want to write a function in the form ax plus h squared plus k. Why would we ever want to complete the square, as it's called? Okay, so if we write f in this form, f of x equals 2 times x minus 7 over 4 squared minus 129 over 8. And we want to minimize this. Okay, we've got to think what can we do to make this as small as possible? So if we split this function up, if we look at this function carefully, okay, what can we do about this 2? There's nothing we can do about it. We can't make the 2 any smaller. It's stuck like that. And this constant term, there's nothing we can do to change this constant term. It's always going to be, there's always going to be a minus 129 over 8 in this function, or term. But we can do something to minimize this. So the only thing we can minimize in f of x is the term x minus 7 over 4 squared. And how do we minimize x minus 7 over 4 squared? Well, we know that it has to be greater than 0. So it's always greater than 0. So the smallest we can make it is 0. So if we want to minimize f, then we want to minimize this x minus 7 over 4 squared. And if we want to minimize x minus 7 over 4 squared, then we want it to be 0. And when is it 0? Well, it's actually really easy to read when it's 0. It's only 0 when x is 7 over 4. That's why this completing the square is so useful, because we can immediately find the value of x that makes f minimum. Okay, so we have found x such that f of x, the function, is as small as possible, is minimum. But what actually, how small did we actually make it? So we made that x term 0, so we've got 2 times 0, and then there's the minus 129 over 8. And so we just see that the minimum value of f is minus 129 over 8. We can't make it any smaller than this. So this is our minimum point of f. Okay, now on to part C. Explain why f must have 2 real roots. Okay, so our f here, f of x, we've been writing it in this form: 2 times x minus 7 over 2 squared minus 129 over 8. And this is the other reason why we would want to write a function in this form, in where we've completed the square. Okay, so why does this have 2 real roots? Well, there's actually this rule. So when we've completed the square, when we have a function in the form as they asked for it, a times x plus h squared plus k, then the function has 2 real roots if a and k have different signs. Okay, why is that? Well, actually, let's just finish this off. So a equals 2 and k equals minus 129 over 8. So f has 2 roots, 2 real roots. So this is actually all you would need to say. Give the explanation that if a and k are different signs, then the function has 2 real roots. And when I say different sign, 0 wouldn't count. So 0 doesn't really have a sign. So if k is 0, then you don't necessarily have 2 real roots. Actually, you don't have 2 real roots. But if they have different signs, if one is a plus and one is a negative, then you have 2 real roots. And now you could probably skip on to the next question here, but I want to show you why this is true. In general, so if we have our function So you can skip to the next question if you want, but for those who are interested, and this is sort of where the minus b formula comes from. So I might even do that as well. So a times x plus h squared plus k. So when does this have real roots? So if we allow this to equal 0, so we can investigate its roots. So now we want to solve for x, and it's actually not that hard to do. So we bring over the k, a over x plus h squared equals minus k. And now we divide by a, so x plus h squared equals minus k over a. And now we square root both sides. X plus h equals plus or minus the square root of minus k over a. And then, let's just go over here. X equals minus h plus minus the square root of minus k over a. Okay, so this is the root, and actually this is the root in general. So whether or not this is a real number, this is a root that will work. It might be a complex root, but it's a root. And so when is it real? Well, it's real when minus k over a, the term in the square root, it's real when this is positive. Okay? And so this is positive when k over a is negative. And so if k over a is negative, then k and a have different signs. It's negative when they have different signs. Okay, and so this gives us two different real roots. Okay, well, what happens if k is 0? Well, if k equals 0, then this whole term here equals 0, and x just equals minus h. That's the only solution. So when k is 0, so k equals 0 implies x equals minus h. So that means that f has one real root. So I'll do a video some other time about how we get the minus b formula, and it's something very similar to this. As you can maybe sort of see here, this isn't, well, it's not quite the minus b formula, but it looks something like it. It has a minus term, and then it has a plus minus a square root. So you could see how it could be related to the minus b formula. But I'll have that for another video. This video will be long enough. Okay, so now on to part 3. Write the roots of f of x in the form p plus minus the square root of q, where p and q are rational numbers. Okay, so, well, we've actually sort of done that for people who listen to my spiel about why f has two real roots if a and k have different signs, which is just this section here. Then we actually already wrote this. So in general, the roots of the roots of the function f are the if we have our function f of x equals a times x plus h squared plus k, so just the general form, then the roots x plus is minus h plus the square root of minus k over a, and the other root is minus h minus the square root of minus k over a. And now we can just fill these in. So in our case, a equals 2, h equals minus 7 over 4, and k equals minus 129 over 8. So if we plug that in, we'll get, for the first one, x plus equals 7 over 4 plus the square root of minus 129 over 8. Sorry, minus this, because it's minus k, all over 2. And x minus equals minus 7 over 4, so just 7 over 4, minus, and then this term again, minus 129 over 8 divided by 2, and our roots are 7 over 4 plus the square root of 129 over 16, and 7 over 4 minus the square root of 129 over 16. Because remember, they asked us to answer in the form p plus minus the square root of q, where p and q are rational numbers. So we can just write x equals 7 over 4 plus minus the square root of 129 over 16. And these are the roots of f.